Hi everyone! In this video, let's discuss how to change material properties dynamically in a running game, so blueprints controlling materials. And here I prepared an example, a portal building where the levers control the specific parts of this building and every material is synchronized. And here also the aperture is connected to the glow, the energy flowing through the cables and the glow on the columns around it. Whenever I close it partially, it becomes dimmer. When I close it completely, they become black. Here I have buttons that change the color of every material at the same time. So I will discuss the ways that you can do that and their performance implications as well. But let me start with the basics. Let's copy this module and what to do to set material property from Blueprint. The first thing, let's create a material, basic math. As you probably know, in Unreal you have constant properties done with constant, let's say vector, and you have vector parameters which allow you to give a name to a variable like that, and then you can right click on a material and create a material instance. Am I yellow or am I red? And now these properties we created are exposed here, but it doesn't duplicate the code of the produced shader. So there is a single copy of this program that the material is compiled to, and just the properties change. So yeah, it basically works like a standard material, despite it's just an instance. So in Blueprint, we will need a dynamic material instance, because whatever we create in the content browser, in the cooked game, it's set in stone. You can't change that. It's changed during editing of the game, but then it's cooked and it's constant. So let me create a blueprint of type actor, BP temp mesh, okay, and let's add a scene and add a static mesh. I will make it movable to be able to change stuff in real time, and I will disable shadow casting for performance. Okay, and my mesh would be this fortress wall. Cool. As the material in the second slot, let me use this basic matte. Okay, let's replace it. Alright. Now, to set the color in Blueprint, what we need to do is in the event graph, on begin play, so when this mesh is first seen in the game, basically when the game starts, we want to take the static mesh and create a dynamic material instance. When we click on the mesh, we can see it's element 2, so element index 2. Source material, you can either use something from the content browser, or you can take the static mesh and get material in the rendering tab, get material index 2, and use it as the source. Okay, if I leave it like that and play, nothing will change. But now it created a new material instance. I can now take this material and set vector parameter of name, color, because that's what we set in the material, and the value red. Okay, So when I play the game, it will be red. Like so. Now, there's a little problem. Let me first hide this mesh. Is visible in game? No. Okay. When I press tilde and say start scene rendering, there is a counter on the very bottom called mesh draw calls. Currently it stands at 132. So what are draw calls? These are commands that the CPU needs to send to the GPU whenever it wants to draw anything. So when I want to draw a mesh with a given material, then for every material in this mesh, I need to send a draw call. When there is 10 copies of the same mesh with the same materials, it's good because a single draw call can pass an array of transforms but use the same mesh with the same materials. So you can draw hundreds of copies of the same thing with a single draw call. It's called batching. But otherwise, draw calls are very expensive, especially on PC, because they come through the driver. So we want to avoid them. We want to have as few as possible. The problem arises that when you create a dynamic material instance, you basically break this batching, because now every blueprint will have a new material. So it means it needs a new draw call. When I unhide that and copy, play the game, there is 134 draw calls. Let's make some more copies and play. 140 draw calls. That's because they are not all in view. Okay. 165 draw calls just to draw this few meshes. The problem is that we've drawn the whole desert with thousands of cubes and nothing like that happened. But that's because they have a common material, and that's because I use instancing. How to fix that? Instead of doing dynamic material instances, we rely on a mechanism that's called custom primitive data. So back to our material, I click on this parameter, and here on the bottom I have use custom primitive data, which I set to yes. We have much fewer options now. That's because custom primitive data are not a true parameter. They are, let's say, raw data that Unreal stores for every mesh in the world. But the great thing is that no matter how many copies you have, the material will be the same instance, because these data are stored per mesh, not per material. So basically, these are 32 scalars that you can use for free in every mesh in the world. And they are independent of each other. So the problem is with this nice optimization that we lose the name of the parameter. Of course, it's a name here, but it's just for convenience. What matters for the code is this index. So here we have index from 0 to 31. And the vector of 4 uses 4 scalars for each channel. When I set it to 0, it says index 0, 1, 2, 3. And it's your problem to manage that there are no conflicts, that materials on the same mesh know what goes into which index. So for example, I also want to control roughness. Just it's a name for me, because as I said, it doesn't matter. Use custom primitive data. I can't use 0 because it will refer to the same field. I have to use 4, because it's, bigger than this value. Now I save it and everything will be black. Unfortunately, that's because they have no defaults. They are uninitialized by default. They are always 0 when you start, The good thing is that Unreal by itself doesn't use them for anything. They are free for you to use. Okay? Now what's the difference? As I said, there is no material instance now. It's all the same material. You can make instances of that, but there is no need to make a dynamic material instance. So I get rid of this thing, and instead, on the static mesh, I do set custom primitive data vector4. Data index is the same as we set in the material. So 0 for the color and 4 for roughness. So I also set custom primitive data float. For roughness it will be 4. So as you can see, it's more tricky to manage, but the gain in performance is well worth it. Okay? I set my roughness to be 0.3, whatever. Or even better, I will expose it. Promote to variable, and I'll call it roughness. Okay, and here, let me call this. This is a vector4. This is not a color. So when I create a color and name, type is linear color for the colors you want to send to materials. So I have my linear color. I expose it to be editable for the user. When I have my color, I can't connect it directly. It says only exactly matching structures are considered compatible. So what I have to do is I have to split this pin and split this pin, and unfortunately connect these one by one. Okay? Now when the game starts, it will set my color to whatever I set here. Let's say red. Let me play the game. And yeah, they are red. All good. But the difference is that this time there is only 137 draw calls instead of 160. Perfect. Now to prove the point, let me create another material that will use that. Basic 2. And this time it will take this color but desaturate it by 50%. Okay? 0.5. Cool. And it also uses index 0 for color and 4 for roughness. So it's good. And now in the static mesh, I will use this new material in this slot. So unfortunately, again, as you can see, black by default. When I play, it's pink, desaturated red. When I change this red to something, I don't need that anymore. When I change this red to blue, it will be the same in the game. All good. But now it's even better because I can actually set this parameter differently for every mesh because we no longer rely on materials. So here I have the parameter I exposed, this color, and this mesh will have color green. Okay, I play. This one is green, but the draw calls are still and at 137. So I can have individual values for hundreds of meshes basically for free. Now, the problem is it's black, right? There is a workaround I can suggest that in our materials we can add a property and call it a scalar, and let's call it is controlled. is controlled. Also use custom primitive data. I will shift them a little. This will be 0, this will be 1, this will be 5. Okay, so if it is controlled, so if A is equal 1, then use my custom color. The same with roughness. If its controlled is 1, then use this roughness. Otherwise, or if it's bigger, whatever. Otherwise, use a constant parameter. So a parameter vector color default, which in my case will be bright green. Okay. So if is controlled is enabled, let's use color default. If it's disabled, sorry. Otherwise, use color, and this goes to base color. The same with roughness. My default roughness will be 0.4. Okay? Like so. Is controlled will be 0 by default, of course. So now I will repeat the same thing in the second material, in this basic 2, but this time the saturation kicks in. Okay, so at least I have some color by default. It works. Now in the blueprint, in begin play, whenever I want to control this, I will take my static mesh and set custom primitive data at index 0 to 1. So it means that it is controlled. Okay, and here data index has changed. 5, 1. Cool. So this is my entire setup. I use this isControlled parameter at index 0 to tell the mesh whether it should use the default color in editor or the gameplay controlled value. Now when I play, they are controlled. They change the color. Okay, so this was a synthetic example. Let me delete this stuff. Alright, let's go to our lever. How does it know which meshes to control? Basically, I created an array called meshes to control and a second actors to control, because it depends on the type of the thing to control. And I can add elements and use the picker to select something. It's a built-in feature of arrays in Unreal. Now, when I open it, here it is, meshes to control. So it's a variable of type static mesh actor, and here it's array instead of single variable. It's instance editable, so I can edit it on the level. And now, for every actor in this loop, I set custom primitive data. For every mesh, I set custom primitive data, as I did in the example before. And for every actor, which is of my custom blueprint type, I created a function in this type that's called setMaterialProgress. So my BP gameplay materials controllable mesh has a function called setMaterialProgress, which sets the custom primitive data, but at the index I set. That's because I thought that maybe I will have different materials in different meshes, so I want to be able to change this index for every blueprint type. So yeah, basically that's it. I have these arrays, and the rest of this complex machinery that you can find in example files is whether the input is pressed then interpolate between one color and another, and between one rotation and another. So there's one thing to show here that I think is a really good practice: to keep the things you control between 0 and 1. So here I have animation progress variable. By default it starts at 0. Let me disable that. And whenever this is moving towards the full rotation, I interpolate the value to go towards 1. So at this position it will be 0, at maximum position it will be 1. Between them it will be something like half. I recommend video about interpolation if you're interested in that topic and don't know already. So let me open the material and it should make it clear. It's fairly complex because I have a lot of animation here, so again I recommend to check the example files. But at the heart of it is my custom primitive data at index 0. I called it material progress, and I interpolate every value using this material progress, the same thing. So here I have my emissive between a glowing color with an extra texture. So this glowing emissive is the thing here, this border. But there's also transparency of the window. This one is transparent, while this one is not. And that's also controlled here by a lerp using material progress between 0 and 1. It either reads the background behind it, or it sends a flat color at value 005. Everything controlled by a single float. Now, when I have a glowing column here, it's called Fortress Glow, I also have material progress at index 0 that multiplies my emission strength, my emissive color. So this uniformity of the parameter between every material and every blueprint makes it very easy to make new materials here for this scene, because you only have to follow this index 0 that will be something between 0 and 1. So the same with rotation. I have a variable here, rotation minimum, which is 0 degrees, and rotation maximum, I set it on the beginning to be 55 degrees. And I control this rotation with the same variable, this material progress or animation progress. I interpolate between minimum and maximum rotation using this value as the alpha. So that's why it's perfectly synchronized with the glow. When this is at half, the emission strength is half and the transparency is also half. When this is maximum, this is glowing super bright, the energy flows at the maximum level, and the rotation is at 55 degrees. So yeah, I really recommend to keep the values you control within a 0-1 range. Now, for the buttons, let me remind you what they did. When I have these folds open, the button controls the global color, like so. And this can be done much easier than with custom primitive data. If you want to have something global, you right click, go to materials and textures, and create a material parameter collection. MPC globals. Then you can add vector parameters and scalar parameters. So for example, if you want a global color, global colors of teams. So for example, this will be team 1 and there will be a team 2 let's say in a multiplayer game, right? You have two teams competing with each other. One will be red by default, the other will be blue by default. Okay, and there's also scalar parameters. You can do the same trick like I did with isControlled in the material custom primitive data. So let's say, is the game running? Is the game running? No, it's not. 0 by default. Now, let's say that whenever I press this button, this value should change. So, in Blueprint, I have set vector parameter value, and you do it by right click, set vector parameter, not on materials, but just like that. Then it allows you to select a collection. Here you can select this collection that we made and choose the parameter you're interested in. Team 1, Team 2. In the case of this fortress example, it's gameplay materials collection and it's glow color. This example is fairly more complex, so let's skip it, but this is what you need to know. Set vector parameter value or set scalar parameter value. Now, in the material, it's super easy to use. Basically, you right click and collection parameter, select the collection and select the name. And basically that's it. And the upside is that it's also visible immediately in the editor. So yeah, I used it exactly in this manner. So in this material, in basically every material I created for this scene that's dynamic, that's animating, I don't use vector parameter because it will be yellow. Instead I use the green one, which means it comes from a collection. Collection parameter glow color. Okay, so you can see it's green here. It's also green here. And in every material I prepared for the scene, I use this parameter collection. So that means that I can now control that with a single click of these buttons. Simple, very effective. I hope you enjoyed this example, and I wish to see the solution in your games now. I think the possibilities with custom primitive data and global material parameters are really endless, as well as the great optimization that using custom primitive data can give you. So, see you around and cheers!